Hi, in this video we are going to see about GPRS. GPRS, first generation analog system. In GPRS, which consists of third generation, fourth generation systems. General Packet Radio Service is GPRS. General Packet Radio Service. General, it is not restricted to GSM use. Packet radio enables packet mode communication over air. Service, not system, existing BSS infrastructure is used. It requires many new network elements into NSS. Provides connections to external packet data networks. Main benefit is its resources are reserved only when needed and charged accordingly. Connection setup times are reduced. Enables new service opportunities. GPRS provides packet switched connection from MS to packet data networks. Different operators' GPRS networks are connected through an interface. It uses packet switched resource allocation. Resources allocated only when data is to be sent or received. Flexible channel allocation. 1 to 8 time slots is used. Available resources shared by active users. Up and downlink channels reserved separately. GPRS and circuit switched GSM services can use same time slots alternatively. Traffic characteristics suitable for GPRS are intermittent bursty data transmissions, frequent transmission of small volumes of data, infrequent transmissions of large volume of data. So the applications are standard data network protocol based. IP based applications are World Wide Web, FTP, Telnet. Any conventional TCP IP based applications. X.25 based applications are packet assembly, disassembly type approach. GPRS specific protocol based applications are point to point applications, toll road system, UIC train control system, point to multi-point applications, weather info, road traffic info, news, fleet management, SMS delivery. This figure shows the GPRS architecture. The dotted lines are signaling interface and the solid lines are mentioning the signaling and data transfer interfaces. Functional view on GPRS. There are two network nodes used to offer packet data service called GPRS support nodes. First one is serving GPRS support node SGSN and second one is gateway GPRS support node GGSN. SGSN functionally connected with BSC physically can be at MSC or BSC site. One for few BSCs or one per every BSCs. One SGSN can support BSCs of several MSC sites. The main functions are authenticates GPRS mobiles, handles mobiles registration in GPRS network, handles mobiles mobility management, relays MO and MT data traffic. TCP IP header compressions, version 4.2 BIS data compression, error controls are carried in SGSN. It collects charging information of air interface usage. Gateway GPRS support node GGSN is typically located at one of the MSC sites. One or few per operator. The main functions are interface to external data network, reassembles to a data network router, forwards end user data to right SGSN. It routes mobile originated packets to right destination. It filters end user traffic and collects charging information for data network usage. The data packets are not sent to MS unless the user has activated the PDP address. Other elements are not defined with GPRS. Routes packets from SGSN, GGSN of one operator to a SGSN or GGSN of an other operator. Provides protection against intruders from external networks. DNS, domain name server. It translates addresses from GGSN 1 format to 123.456.67.89 format, i.e. used as IP version 4 or IP version 6. Charging gateway collects charging information from SGSN and GGSN. TMSC, point to multipoint service center, PTM multicast downlink broadcast, no subscription, no tapering. PTM group call is closed or open group. Base station subsystems. Base station system needs to enhance to recognize and send packet data. BSS includes BTS and MS. Network subsystems. It consists of a number of SGSNs and also consists of a number of MSEs. It helps in authentication, operation and maintenance of subsystems. It consists of a number of MSE, BTS and BSEs. MS have GPRS capability. It stores a CKSN, cipher key sequence number, a logical identity. Gateway subsystem consists of SGSN and GGSN. It provides connections to other network and PDA, that is public data network. Security based on GSM phase 2. Authentication. SGSN uses same principle as MSC VLR. It gets triplet, send RAND to MS, wait for SRES from MS and use KCs. MS cannot authenticate the network. Key management in MS is key generated same way from RAND using KI as in GSM. Ciphering algorithm is optimized for GPRS traffic. Ciphering is done between MS and SGSN. User confidentiality. IMSI is only used if a temporary identity is not available. Temporary identity is exchanged over ciphered link. Interworking with GSM services. Interwork with the GSM services through GS interface exists. Type of the location update procedure is indicated by the network in the response message to MS. Effects on different MS classes if GS does not exist. A-class mobiles must use conventional GSM service via normal GSM channels. B-class mobiles won't get simultaneous support from the network, depending on MS design. MS can try listen both paging channels simultaneously by themselves. MS does IMSI detached and use only GPRS service. No effect on class C mobiles as simultaneous service are not supported. Combined GPRS and IMS attached. To save radio resources, MS indicates its request for combined attached. MS sends combined GPRS and IMSI attached to SGSN. SGSN may authenticate the MS. SGSN informs MSC VLR about the new MS. Combined location and routing area update. That is used to save radio resources. MS indicates its request for combined update. This is done when both location area and routing area changes at the same time. Combined location and routing area update is not done if MS has CS connection. Quiz. Thank you.